This is video number 5 for the assembly programming and reverse engineering course. And in this video I will talk about the move and the load effective address instruction. And this is a code that we will later assemble. And the first instruction is default rel. Default rel, that means that we want to use relative addressing. Okay, so what does it mean? If we take a look at this command, move rex, and then in brackets this memory address, that means that we dereference this memory address, so we move the data at this memory address into the rex register, and that is then called absolute addressing, but this is not important for us for normal user mode applications. So we need to use relative addressing. Then we can use this command, move rex rel text. That means that this is, so if we would type something like this text, that wouldn't work without default rel, because assembler would treat that as a hard-coded memory address, and that will not work. Okay, so if we take a look into the data section, here we have this variable text db hello, 0, and the assembler has, so in simple words, it converts this variable into a memory address. And in order to do that, we need to use a rel command. But if we type default rel at the top of the program, then we don't need to use this command. So then we can just keep it as it is now. Okay, the next command is extern exit process. Exit process is that's a Windows API function, and that is used to just to terminate a program. We call it at the end of this program. And extern, that means that exit process is a external function that we want to import, and we import it from the kernel 32 DLL, and we link it against the kernel 32 lib. We're doing that with this with a script that we will use to assemble the file. I've talked about that also in the first video. Okay, so this is new, this -0 command, because that means that we want to deactivate the optimization for the binary files, because otherwise the compiler would, with the assembler, would optimize our code. For example, here we can see move rex 1, and with optimization activated, we would see move eax1 in the binary, and therefore, we just deactivate the optimization for now. And the MSDN, so go to Google, type MSDN exit process, use also more detailed explanation about the function, and you can see library kernel32.lib dll kernel32.dll. And if we go back to the script, here we can see link, and you can see the kernel 32 lib. So we link against this library in order to be able to use this exit process symbol in our program. Okay, the next command is global main. That means that that main is our entry point. This is entry point, and this is assembly code that we are going to execute later. And then we have this section, the data section. This is a section for initialized variables. In this case, we can see text db hello, 0, and that means we want to declare a variable with a text or with a data hello. In this case, there are 5 bytes plus a null terminator, so in total 6 bytes. And the null terminator is, so it's used by some functions to determine the end of the string. But yeah, in general, it's a good practice if you always try to null terminate the strings unless you have any reason not to do it. And the next command is text length equ. dollar minus text and EQU, that is a constant value. And this variable text length, it gets now the value 6 because hello is 5 characters plus null terminator. Then we have 6 characters in total, and yeah, text length gets just this value. And yeah, of course, in the NASM docs, there's also an explanation for this constant value macro. It should be in your NASM folder. Here it is, nasm.doc.pf. And then on page, what is that? I think it was 38. Here you can see yeah, the EQU defining constant. And on page 104, there's also an explanation for the relative addressing. Okay, the next command is this one, number dd3. That means define the word. So we want to define the word, a double word, and the value is 3, and the double word has a size of 32-bit. There are also other data types, and yeah, db. db, that means define byte. And here are the other data types. But yeah, I will not talk about that now. It's something for maybe for the next video or something. Okay, then we have the section BSS. This is used for uninitialized data. So if we have something like this, buffer SB20, for example, that means that we want to reserve 20 bytes in the program. But that's also something for other video. Then we have the section text, and here's the assembly code. And now we can install the x64 dbg debugger. So go to this website, x64dbg.com, then download the file. I've downloaded already all the data. I create a new folder, I call it x64dbg. And then I will extract all the data to this folder. Then open the release folder, double click this one. And now click install. Then click x64dbg, that is for 64-bit applications. That is also what we write in this course. So we will write only 64-bit assembly code, and this is for 32-bit applications. Okay, so this is still in German. I need to change that. Okay. Now we can assemble the program. So I will just run this file now. And the exe file that was created now, it's called file.exe, because the file with assembly code is called file.asm. And here it is. Now click on this folder icon. Now I need to go to the binary file. Then open the file. Oh, and yeah, this is still in lightning mode. So if you prefer dark modes, then just click on options, theme, and then select dark. Okay, now here we can see that we are currently an ntdll.dll. That is not the code that we have written. And therefore we need to press this run button until we see our assembly code. Okay, now here we can see the code. And what we can do now is, so if we don't want to click all the time on this button, then just go to Options, Preferences, and keep only this one activated. I will restart the program. Okay, and now we are here in the assembly code that we have written. Okay, so the first command is this one, sub rsp28, and 28, that is a hex value, and in decimal that is 40, and why sub rsp40 or in hex sub rsp28, we need to use that for stack alignment and to reserve enough memory for this function. So we reserve shadow space, but I will talk about that probably in the next video. There's many stuff where we could now talk about, but I don't know if that makes so much sense. So it's probably better to split different topics in different videos, otherwise the video will be way too long probably. Okay, so this is the first command. Here we can see this this memory address. We can see it's green, so that means that this is the next command that we execute when we click this button step into. Or we can also just press F7, and I will press or I will click this button now. Okay, so the next command is move rex 1, and here on the right hand side we can see all the memory, all the CPU register, and now the rex register holds this address currently, and when I run it, then it will change to 1. So rex is now holding the value 1. The next command is move rcx rex. That means we move the value 1 to rcx. Rcx is holding this value. And now rcx is holding the value of 1. Then the next command is move rex text. And the assembler has already converted this variable into a memory address. And when I execute this, the rex register will get the memory address. Okay, what we can do now is we can double click this address, or we can press space, then copy this address, click in the hex dump, hold Control, press G, copy and then paste in the address, click OK, and then we jump immediately to the address, or when I scroll down. So now we can't see it anymore, but when I double click on the address, then we jump back to this address. And here we can see the 68, that's the H. Then we have the E, L, L, O, the null terminator, and the value 3. Okay, and the text length, it's, where is it? Ah, okay, now we can see that now. Or, no, yeah, we can. Here it is. Move text length. So it's a hard-coded value in this case. That is what the assembler is doing automatically if we are using this constant. Okay, and now again, take a look at rex. Rex is holding the value 1. And now I click on this button. And now rex points to the variable that is holding the string hello. Using the move instruction for something like that is not ideal. It's better to use the LEA instruction. And LEA, that stands for load effective address. Here we can see now LEA rex keyword ptr ds, and ds, that means that this is in the data segment. Keyword, that is that is because the address, it's a 64-bit address and it's a pointer, and this is address then. Okay, so technically it's, for now it looks like that it's doing the same. So when I execute that, nothing will change here. Well, yeah, we could just move it to 0, then we can see that actually something is happening. Now I execute it and we can see it gets again the memory address. But yeah, using LEA is more efficient than using the move instruction. So whenever you want to move the memory address from any variable into a register, like here, then just use the LEA command. What we also can see here is that the opcode instruction is pretty long, and for LEA it's way shorter. And what we can do is we can use this with without the brackets, or this one with the brackets. In this case, there's no difference. Okay, and the next command is this one, move BL byte rex. We know already rex is holding the memory address of text, and byte, yeah, that's just a byte, and that means we move the first byte to the BL register. Okay, let's take a look. BL, that is, here it is. The last two zeros, that's the BL register. So RBX, take a look at this one, it's 0. Now I will execute it, and then we will get the first letter of the string into BL, and there it is. The next one is move rex 0. So rex will get again the value 0. And yeah, again, if you want to set a register to 0, then it's better to use the XOR instruction. I think I've talked about binary operations in the last video. Okay, so this is now 0. When I execute this XOR rex, it's again, that just stays 0. And if we take a look at the opcodes for move rex 0, it's a pretty long opcode instruction, and here it is very short. Okay, and the next one is move rex number. Now we want to move the address of the number to rex. It's basically the same like here in this example. Okay, but at first I will double click this address, and then here we can see the value 3. And let's run it, and now rex points to the variable number. And again, okay, so I will set this again back to 0. We are using the LEA instruction now to load the effective address. And we can see LEA rex is pointing again to the memory address of the number variable. And again, yeah, you can use it without brackets or with brackets, doesn't matter. And here now we are going to dereference the memory address. Okay, so here we can see a move RCX keyword PTR DS, and it's the memory address. And here we can see it's in brackets. So if we are using the LEA command, and if we are putting the variable in brackets, it's the same as if we would use LEA command and not put the variable in brackets, but if we are using the move instruction, then there's a big difference, because now what we're going to do is we will move the data from this variable into RCX. Okay, so take a look at us. Let's take a look at RCX. Currently it's holding the value 1. Now I will execute it and then it will be 3. Here it is, now it's 3. And then we have this one, with a constant. And RCX will get the value 6. Now it's 6. Then we have this one, X or RCX. So this is the first parameter for this Win API function. But yeah, we'll talk about that in more detail also in another video. And now I will execute it. And yeah, now we are in the exit process function. I'll just execute it now, and now it's terminated. And yeah, that's it basically for this video.